$2,200. That is what the average American household will spend on heating and cooling this year. Roughly half of that, over $1,000, goes to air conditioning alone. In the southern states, that number climbs past $1,500. Exposed to July in Texas or August in Ohio, your central air unit pulls 3,000 to 5,000 watts per hour, every hour for months. The compressor alone consumes 80 to 90% of that draw. The system cycles on and off, 8 to 12 hours a day, 5 to 7 months a year, every year for the life of your mortgage. 3 hours east of Columbus, Ohio, in Holmes County, there are Amish farmhouses with no compressor, no condenser coil, no ductwork, no refrigerant, no thermostat, no monthly electric bill, and no connection to the grid. On a 95-degree afternoon, the interior of those homes sits between 72 and 78 degrees. Not because the families are suffering, because the house was designed to do this from the day the first rafter was raised. The method is not a product. It cannot be purchased, financed, or serviced. It is geometry. This is how it works. Why it has worked for over 2 centuries, and why the $65 billion American HVAC industry has no interest in you ever learning about it. The physics behind this method is older than the English language. In the city of Yazd, Iran, one of the oldest continuously inhabited cities on Earth, towers rise above the rooftops. They are not minarets. They are badgers, wind catchers. Some have stood for over 500 years. The tallest at the Daulat Abad Garden rises 33 meters above its pavilion. These towers are open at the top, divided into vertical shafts by interior partitions. When wind strikes the tower, air is channeled down through the shafts into the rooms below, cooling the interior by convection. When there is no wind, the sun heats the tower's masonry walls, which causes the air inside to rise and draw cooler air from the basement and courtyard through the living spaces below. The system works in both conditions: wind or no wind, day or night. The cooling effect is measurable. Researchers have documented indoor temperature reductions of 14 to 22 degrees Fahrenheit compared to ambient outdoor air. No electricity, no moving parts, no maintenance. A 2021 study published in the Journal of Building Engineering confirmed that wind catcher systems can provide up to 9.6 kilowatts of passive cooling power at moderate wind speeds and deliver over 30 air changes per hour. Numbers that rival small mechanical HVAC units. The same study noted that wind catchers can satisfy indoor air quality parameters established by CIBSE, the Chartered Institution of Building Services Engineers, even in low wind conditions. More than 7,000 modern wind catcher-inspired systems have been installed across the United Kingdom in the last decade alone. In commercial buildings, shopping centers, universities, the principle has not changed since the Achaemenid Empire. Air rises when heated. Cooler air replaces it. A vertical shaft amplifies the effect. A structure that is open at the top and draws air from below creates a continuous, self-powered cycle of ventilation and cooling. This is the stack effect. It is not a theory, not a projection. Measured, verified, documented. The Romans understood it too, though they applied it primarily to heating. The hypocaust system. From the Greek hypo, under, and kaustos, burnt, circulated air beneath raised floors and through flues built into walls. Vitruvius described its construction around 15 BC. What matters here is not the furnace, it is the flue. The Romans built vertical channels into their walls specifically to exploit the principle that heated air moves upward and creates a draft that pulls replacement air from below. They control the temperature of entire buildings, bathhouses, villas, public halls, by manipulating the height, placement, and diameter of these channels. The caldarium at the baths of Caracalla in Rome could reach 120 degrees Fahrenheit using this principle. No fan, no blower motor, no ductwork. Just physics, masonry, and vertical space. The stack effect, the chimney effect, the thermal siphon. Every civilization that understood it built structures around it. The Persians built wind towers, the Romans built flues, the Amish built attics. The Amish attic is not an attic the way a modern American builder uses the word. In a conventional American home, the kind built by the millions since the 1950s, the attic is a residual space. It is the dead air pocket between your ceiling and your roof. It was not designed, it was left over. Builders insulate the floor of it, punch a few vents into the soffits and the ridge, and move on. The International Residential Code calls this an unfinished space between the ceiling assembly and the roof assembly. That is all. An accident of geometry managed with fiberglass and a few aluminum grills. In Amish home construction, particularly in the older communities of Lancaster County, Pennsylvania, Holmes County, and Geauga County in Ohio, and LaGrange County, Indiana, the attic is the engine of the house. It is designed first, not last, and it is designed to move air. Here's the method. The Amish build with steep roof pitches, typically 10 to 12 to 14 to 12. A standard modern American residential roof runs 412 to 612. The difference in volume is enormous. A 10-12 pitch on a 30-foot wide house creates an attic with a peak height of roughly 12.5 feet. A 412 pitch on the same house creates a peak of 5 feet. The Amish attic is not a crawl space. It is a room, a tall room, a room with a purpose. At the peak of the roof, a cupola is installed, not for decoration, though they are often handsome structures built of white pine or cedar with louvered sides. The cupola is a ventilation chimney. Its louvered openings, typically on all four sides, allow air to exit regardless of wind direction. The cupola sits at the highest point of the structure. Inside the house, the first floor has operable windows, large double-hung windows that open at both the top and the bottom. Some Amish homes use transoms above interior doors to allow airflow between rooms. The basement or ground floor sits on stone, concrete, or thick masonry, materials with high thermal mass that stay cool. The system works as follows. Solar radiation heats the roof surface. The roof heats the air inside the attic. That air rises because heated air is less dense and exits through the cupola at the peak. As the hot air exits, it creates negative pressure inside the attic space. That negative pressure pulls air upward from the living spaces below through stairwells, ceiling vents, or intentional openings between the second floor and the attic. As air is pulled from the living spaces, replacement air is drawn in through the first floor windows, particularly from the shaded north side of the house, where porches and deciduous trees block direct sun. In many Amish homes, a summer kitchen, a separate cooking structure attached to or near the main house, keeps the heat of wood stove cooking entirely outside the thermal envelope. The air path is continuous. Cool air enters low. Warm air exits high. The taller the vertical distance between inlet and outlet, the stronger the draft. The steeper the roof, the more volume the attic holds, and the more air it can process. The cupola is not a decoration. It is a chimney without a fire. The physics has not changed. In 2013, researchers at Carleton University in Ottawa published a study in the journal Applied Energy examining roof solar chimneys, structures functionally identical to the Amish cupola attic system. Their simulations modeled a detached single-story home in 4 climate zones, using a gap under the outer roof layer to create a ventilation path from the interior to an exhaust plenum at the peak. The results showed that in homes built with high thermal, mass, and proper ventilation controls, cross and stack ventilation removed most of the cooling load. In moderate climates, the solar chimney approach reduced mechanical cooling requirements to near zero. Near zero. Not a theory, not a projection. Simulated, modeled, published. The Amish did not read that paper. They did not need to. They have been building this way since the 1700s, when their ancestors settled in Pennsylvania and brought with them the Central European tradition of steep-roofed farmhouses designed for ventilation and grain drying. The steep roof sheds snow, yes. It creates usable loft space, yes. But its primary thermal function is to act as a solar-powered exhaust system that runs every day the sun shines, pulling heat out of the living space and replacing it with cooler air from below. The numbers are straightforward. A family in Lancaster County builds a 2-story farmhouse with a cupola, steep pitch, high ceilings on the first floor, and properly placed windows. Total additional cost of the cupola and roof framing compared to a standard 5 to 12 pitch. Roughly $3,000 to $6,000 at construction, depending on materials and size. There is no compressor, no condenser, no ductwork, no refrigerant lines, no thermostat, no electrical panel upgrade. A conventional central air conditioning system for a comparable size house costs $5,000 to $10,000 installed. It lasts 15 to 20 years. It consumes $400 to $1,500 per year in electricity, depending on climate zone and usage. It requires $150 to $300 per year in maintenance. Over a 30-year mortgage, that is $16,500 to $54,000 in electricity and maintenance alone. On top of replacing the unit at least once, the Amish alternative costs a few $1,000s once. It requires zero electricity, zero refrigerant, zero service contracts, zero replacement. The cupola may need a coat of paint every decade. The louvers may need a screen replaced. That is the entire maintenance burden. The 30-year cost difference, conservatively, is $20,000 to $50,000. $50,000. That is the cost of not knowing what a cupola does. The question is not whether this works. The question is why it is not standard. The United States HVAC industry, heating, ventilation, and air conditioning, generated over $65 billion in revenue in 2025. The residential segment alone accounted for nearly $16 billion. Roughly 88% of American households use some form of air conditioning. 2/3 rely on central air. The industry adds an estimated 3 million replacement units per year. American consumers spend more than $10 billion annually on HVAC repairs and maintenance alone. This is not a niche market. This is a pillar of the American economy. It employs hundreds of thousands of technicians, engineers, salespeople, manufacturers, and distributors. It is sustained by a single premise, that cooling a house requires a machine. The Amish attic design does not require a machine. It does not require a technician. It does not require a service contract or a seasonal tune-up or a refrigerant recharge or a filter subscription or a compressor warranty. It does not generate a single dollar of recurring revenue for anyone. Now look at the code. The International Residential Code, the IRC, is maintained by the International Code Council, or ICC. The IRC governs residential construction in 49 states, the District of Columbia, and multiple U.S. territories. Section R303 addresses ventilation. Section R303.1 requires habitable rooms to have natural ventilation through openable windows equal to at least 4% of the floor area, or mechanical ventilation in lieu of natural ventilation. Section R 303.4 requires whole house mechanical ventilation for any dwelling that tests at 5 air changes per hour, or fewer at 50 pascals of pressure. The tighter you build, the more the code pushes you toward mechanical systems. Section R 806 addresses attic ventilation. It requires a minimum of 1 square foot of net-free ventilation area per 150 square feet of attic floor, or 1 per 300 if certain conditions are met, including a Class 1 or 2 vapor retarder. The code prescribes a ratio. It does not prescribe a design. It does not mention cupolas. It does not mention roof pitch as a thermal strategy. It does not mention the stack effect as a cooling mechanism. It does not distinguish between a 4 to 12 pitch with 2 passive soffit vents and a 12 to 12 pitch with a 4-sided louvered cupola, a design that produces dramatically more airflow per hour. The code does not prohibit the Amish approach. It simply does not recognize it. There is no line item for passive stack effect cooling via steep pitch attic and cupola ventilation. There is no credit for eliminating the need for mechanical cooling. There is no checkbox, no category, no calculation method approved by ASHRAE or the ICC that a builder could use to demonstrate that a properly designed attic cupola system meets or exceeds the comfort, performance of a 14-SEER air conditioner. No conspiracy, no ban. Just a code that never included it. Now look at who writes the code. The ICC is a nonprofit, but its operations are funded by membership dues, publication sales, and certification fees. Its voting membership includes building officials, but its governmental consensus council includes representatives from corporations and trade organizations across the construction and HVAC industries. ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, develops the ventilation standards that the IRC references. ASHRAE's corporate members include Carrier, Trane, Lennox, Daikin, Johnson Controls, Mitsubishi Electric, and dozens of other HVAC manufacturers. These organizations do not fund ASHRAE out of civic generosity. They fund it because its output directly determines what equipment is legally required in American buildings. Now look at the contractor. A licensed HVAC contractor makes money selling equipment, installing ductwork, and signing maintenance agreements. A passive attic cooling system requires none of those things. There is no licensing category for cupola-based passive ventilation design. There is no insurance product that covers it. There is no manufacturer's warranty to pass through. There is no annual service call. A contractor who recommends this method eliminates their own revenue stream permanently. Now look at the appraiser. When a house is sold, an appraiser assesses its value by comparison, comparable sales, standard features, recognized systems. A central air conditioning system adds measurable value. It is a line item on the appraisal form. A cupola with a steep pitch attic designed as a thermal chimney adds nothing. It is not a recognized feature. There are no comparable sales. The appraisal system cannot see it. To the market, a house without AC is a house without AC, regardless of whether its interior sits at 74 degrees in August. No conspiracy, no ban. Just a code that never included it, contractors who lose money if they recommend it, and an appraisal system that cannot count it. The result is indistinguishable from prohibition. The method was not lost. It was buried. But it is not difficult to recover. If you are building new, the materials are standard. Framing lumber, roof sheathing, a cupola, either site-built from pine or cedar, or purchased from any number of Amish or non-Amish manufacturers. Cupola prices range from $300, for a basic louvered model to $2,500 for a large windowed unit. The critical design elements are these: a roof pitch of 10 to 12 or steeper to maximize attic volume and thermal draft. A cupola sized at minimum 1.25 inches of width per linear foot of unbroken ridge. So a 24-foot ridge gets a 30-inch cupola at minimum. Louvered openings on all four sides to allow exhaust regardless of wind direction. Interior air pathways, open stairwells, ceiling vents, or operable transoms that allow air to move from the ground floor into the attic space. Operable windows on the first floor, preferably double hung with screens, positioned to draw air from the shaded side of the house. Shade. Trees, porches, overhangs, anything that reduces direct solar gain on the walls and windows before the air enters. If you are retrofitting, a cupola can be added to an existing ridge. The installation requires cutting into the roof sheathing, framing the opening, flashing and sealing the base, and mounting the cupola. A competent carpenter can complete the work in a weekend. Combined with opening up the airflow path between the attic and the living space, and sealing or removing ceiling insulation in strategic locations to allow convective flow, a retrofit can meaningfully reduce cooling loads. It will not replicate the full performance of a purpose-built Amish home because the roof pitch and ceiling height are already set. But the principle still applies: more vertical distance, more ventilation area, more draft. In many jurisdictions, homeowners can pursue this work under an owner-builder exemption. Agricultural structures in rural counties are often exempt from residential code requirements entirely. The Amish themselves are frequently exempt under religious and agricultural exemptions, which is why their methods have survived at all. The materials are standard. The physics has been working in Amish communities for 250 years, in Persian wind towers for over 1,000, and in every chimney ever built since humans discovered fire. The only decision left is whether you act on it. $65 billion. That is the annual revenue of an industry built on the assumption that you need a machine to cool your house. An Amish family in Holmes County, Ohio, cools a 2,400 square foot farmhouse with geometry, lumber, and a louvered box on the roof. No compressor, no refrigerant, no ductwork, no monthly bill. The physics has not changed. The code just never included. It's next time this archive opens on Amish root cellars, how a hole in the ground, lined with fieldstone and packed with straw, stores food at 40 degrees year-round without a single watt of electricity. The USDA has specific regulations about food storage temperature. The Amish method meets every one of them. The refrigeration industry generates $58 billion a year. The Amish root cellar costs $800. If this archive matters to you, subscribe to Amish Build Archives and hit the bell. Every like and every share preserves what they tried to erase. The next archive opens soon.